Hello students, this is Amardeep Singh, your computer teacher, and today we are going to continue with the chapter number system. And in this session we'll discuss about number system conversion, and we'll discuss about the decimal number system to other number system conversion like decimal to binary, decimal to octal, and decimal to hexadecimal number system. So first we'll discuss about the number system conversion. Converting one number system to another number system is known as number system conversion, and in this session and in this chapter we'll discuss about the decimal number system to other base systems to decimal number system, and one base to another base. So we'll discuss all these types of conversions from one number system to another number system. So let's start our discussion with decimal to binary number system. So in this section we'll discuss about converting decimal into binary and converting decimal fraction into binary fraction. Fraction means a number with a floating value that contains a dot. So first we'll start with the converting decimal to a binary number system. Here we are having a decimal number that is 249 with a base 10, and I want to convert that number into a binary number. So first of all we have to divide this number with 2. So let's start with this one. So you have to write 249, and you have to divide it by 2. Then and 12 twos are 24, and 2 fours are 8, and the remainder is 1, and remainder you have to write here on right side, and again divide the same value, the next value, with 2, and you have to divide all the answers with 2. So 2 6 are 12, and 2 2s are 4, and the answer is 62, and the remainder is 0, and again divide it with 2. 2 3s are 6, 2 1s are 2, and the remainder is 0. Now again divide. 15 twos are 30, and the remainder is 1, and next 2 sevens are 14, and the remainder is 1, and again divide it with 2. 2 threes are 6, and the remainder is 1, again divide it. 2 ones are 2, and remainder is 1. And now you have to write all these remainders in a reverse order, starting from bottom to up in this order. So the value is 1 1 1 1 1, then 0 0 and 1. This one is the binary equivalent of the decimal number 249. Next we'll discuss about converting decimal fraction to binary fraction. So here we are having a value 249.15, that is a decimal number, and we want to convert it to a binary number. As we have already discussed that how to convert the integer part of a decimal number to binary, that we have to divide that number with 2, and all the remainders we have to write from in this order, from starting from bottom to up. And now next we'll discuss about how to convert this fractional part into the binary equivalent. So let's start with this one. So now we'll convert this fractional power portion into binary equivalent. So we have to write it like 0.15, and we have to multiply with the base of the destination number system, that is 2. That is the base of binary number system, and the result is 0.30. So the integral part you have to write here, and now the rest of the part, that is 0.30, you can also write here 0 with 2. Then the result is 0.60, and again you have to write this integral part here, and again you have to multiply this portion 6.0 into 2 and write the answer will be 1.20, and you have to write the integral part here, and again you have to multiply this portion, the fractional part, by 2, and again the result will be 0.40. You can write here 0, always you can write here 0, and the integral part you have to write here, and you can continue this process according to the number of decimal places that you want to write after that dot, or this procedure you can continue until either the fractional part becomes 0 or is repeated. In case if the number at end, this number will become 0, then you can stop this procedure, or if the same thing is repeating again and again, or if you want that you want only 2 decimal places, then you can stop there. So next I'll multiply point 0.40 with 2, then the result will be 0.80. Then integral part you should write here, and now here we are having 80, 0.80 into 2, and the result will be 0.60, and the result will be 1.60, and the integral part you have to write here, and now we are in hand 0.60 as the next value. Now you can see that the next value is 0.60, and that we have already done that calculation, so that means the same value is going to repeat next time. So you can stop here to perform this calculation, and now you have to write the portion after this dot. So as we have done in in case of normal decimal integral portion, to convert that to binary number, after the conversion, after the division, we write all the remainders starting from bottom to up here as a result. But in case of fractional portion, you have to write from top to bottom. So you have to write in this order after the decimal place. So after the zero, after the point, you have to write 0, again 0, then 1, then 0, 0, and 1. And this is the procedure to convert a decimal fraction into binary fraction. Next we'll discuss about how to convert decimal into octal number system, and in this section we'll discuss about converting decimal into octal and converting decimal fraction into octal fraction number. So let's start our discussion with how to convert decimal to octal number system. As we know that the base of an octal number system is 8. So that means if you want to convert a decimal number to octal system, then you have to divide this number, the decimal number, with 8, and each remainder that you will get will decide the value of the octal number. So just start with the same way. So here you have to write 249 divide by 8, that is the base of octal number system. So 8 threes are 24, 8 ones are 8, and plus 1 9, so the remainder is 1. Again divide it with 8, and 8 threes are 24, and plus 7 31, so the remainder is 7. And now presently we are having these values 3, 7, and 1. So if you will write like 371, that is the octal equivalent to the decimal number 249. In this way, by dividing the base of octal number, that is 8, with uh, any value with uh, the base of octal number, that is 8, you can convert a decimal number to octal number. Next we'll discuss about how to convert the fractional part of a decimal number into octal fraction. So we have already discussed about how to convert the integral portion into octal number, that is by dividing the base of the octal number, that is 8. So we have already done it. So the value is 249.65, and we have already converted 249 into octal equivalent, that is 371. Now we'll discuss about how to convert 0.65 into the octal fraction. As we have already discussed that if you want to convert fractional part of a number into another number system, then you have to multiply that fractional part with the base of the destination number system, that is 8 in this case. So what we all have to do, we have to write 0.65 multiply by the base of the octal number, that is 8, and the result is 5.20. So you have to write the integral portion of that result here, and then next you have to write this fractional part as 0.20 into 8, and the result is 1.60, and you have to write the integral part here, and now 0.60, that is the fractional part, and multiply by 8, and the result is 4.80, and you have to write the integral part here, and you can further calculate the perform the further calculations also, but you can stop here because that is depending on the number of decimal places that you want to calculate. If you want to perform further calculation, then you have to write it like 0.80 into 8 and so on. So if you want to calculate till this 3 decimal places, then you have to write from top to bottom like 5, 1 and 4. So that will be the result of this fractional decimal number after converting to octal number system, octal fractional. Next, we'll discuss about how to convert decimal to hexadecimal number system. And in this section, we'll discuss about converting decimal into hexadecimal and converting decimal fraction into hexadecimal fraction. So now we'll convert the decimal to hexadecimal, and again we are having the same value 249 with the base 10, that is the decimal value, and we want to convert it to hexadecimal with the base of 16. And here we are having the symbols that we are having in hexadecimal starting from 0 to 9 and A to F. And let's start with the discussion. So first of all, we have to divide 249 with 16. So I'll write 249 here and 16. So let's start with the division. 16 ones are 16, so we'll write here, and the remainder is 8. 6 plus 8 equal to 24, so that means 8 is the remainder. Now presently we are having 89, and 6 fives are 80, and the remainder is 9. So here we will write that 9. So here we are having a value that is less than 16. So presently we are having only two values. One is 15 and second is 9. So if you will write 15 and 9, that is the result of this division, and 15 means, according to the hexadecimal symbols, 15 means F. So the hexadecimal equivalent of 249 is F9 with the base of 16, that is the base of hexadecimal value. So in this way you will be able to convert a decimal value into hexadecimal by dividing the value with 16. Next we'll discuss about how to convert decimal fraction into hexadecimal fraction, as we have already done how to convert the integral part of a decimal number into a hexadecimal number, and the result of 249 is F9. And now I want to convert 0.23 into the base of hexadecimal, that is 16. So we have to multiply this value with the base of hexadecimal value, that is 16. So let's start with this one. So here we are having 0.23, and you have to multiply it with 16, and the result will be 3.68. And next you have to write the integral portion of this value here, and this part again here, like 0.68, and multiply that value with again with 16. And if you will multiply 0.68 with 16, then the result will be 10.88. And now you have to write the integral portion here, and 0.88 here, like 0.88 into 16. Then after multiplying 0.88 with 16, we are having 14.08, and you have to write this 14 here, and again the fractional portion you have to write here 0.08, like this. And you can calculate up to the number that you want, the fractional point that you want. If you want two decimal places, then you can calculate only till two values. If you want three decimal places, that is depending on your wish. So I'll calculate once again. So zero point 0.8 with 16 multiply by, then the result will be 1.28. So I'll stop this calculation here, and even you can continue further, and here you will write the integral portion and stop here. Now presently we are having 3, 10, 14 and 1. So as we have already discussed that we have to write these values from top to bottom order. So in normal cases, when you convert some decimal to some another system, then you generally write the remainder from bottom to up order, but in case of fractional portion you have to write from top to bottom order. And 3 means, in case of hexadecimal, 3 means 3. 10 means, because the 10 is equivalent to the A, so that means here you have to write A. And 14 means E, so that means you have to write E here. And next we are having 1, so the result will be F9.3 A E and 1. So if you want to display 4 decimal places, then this will be the result. And if you want to calculate further, then the result can change according to the number of decimal places. So that is all about how we can convert a decimal fraction into hexadecimal fraction. So that is all about how we can convert from decimal to other bases, like from decimal to binary, decimal to octal, and decimal to hexadecimal, including fractional part of that, all the numbers.